Hello everyone. Here is group 12 and our project is bouncing shape. My name is Jiaxin and here is our teammate Xunlin, Yuzhou, Yiting and Zhenyang. So our project goal is to implement Java code that can bounce complex, deformable and three-dimensional figures consists of 1 million triangle mesh along a window with about 100 small obstacles in it. On the top of the window, we can see the real-time frame rate and the velocity of the figure. The red plane is the ground, while the green and blue plane is the wall of the boundary. You can see in the middle, the green tube in the center is the 1 million triangle mesh, while the small red dots in the scene are the 100 obstacles. The user can control the mesh using keyboard, and the goal is to touch the green tube using the mesh. So the project's background, the first is about 3D graphics. It utilizes a three-dimensional representation of geometric data that's stored in the computer. The geometric data is represented with polygon mesh or triangle mesh, which is a collection of vertices, edges, and faces that defines the shape of an object. And the shading is a 3D rendering problem which varies color and brightness of a surface with lighting. Every line of the user input represents three vertices of a triangle, and we then need to transform this user input into a hash map. So every entry of the hash map, the key is the vertice of a triangle's coordination, and the value is its index. Then the triangle face could refer to its three vertices according to the index. And bouncing also involves collision detection. One naive approach is to use a more simpler shape for collision detection. So we overlay on top of the original object. We then check for collisions based on these simple shapes. And AABB stands for Axis Aligned Bounding Box, which is a rectangular collision shape aligned to the base axis of the scene. A collision occurs when the two collision shapes enter into each other's regions. For example, the shape of the first object is in some way inside the shape of the second object. So basically, we check if the edge of three direction overlay of both objects. If all three edges overlap, so we have a collision. At very first, we implement the bouncing figure in the box without deform. And deforming is a little bit more complicated as we need to consider when is the squeezing and the stretching status, and when is the free status for the figure. The deform position goal is the end point of the squeezing, which could be adjusted by elasticity from the command line, while the free goal is the end of the stretching, and after which the figure is turned into free moving status until next collision. In our project, we use JavaFX as our mainly API and graphics engine. And also we use SolidWorks to create a huge mesh file consists of more than 1 million triangle mesh, and use JavaFX 3D model importers to import the OBJ file into JavaFX mesh view. So here is our block diagram design. There are two major components in total. The animation handles every frame's calculation, mostly in deforming and scaling. And the scene object defines the user interface, including keyboard and mouse control, and the view perspective. The keyboard and mouse handler will affect the motion of the figure in animation every frame. All shapes, figure, and light effects were added to the root object as a sequence, and all of them will be added to the scene finally. The boundary cube is the 100 by 100 by 100 boundary box, and the add mesh function could produce mesh view figure to the root, either from the stl file importer or by building the mesh view from user's standard input triangles. The add obstacles function generates 100 small balls in the boundary cube while avoiding collision with matched figure during initialization. The add cookies function creates a small green cube in the boundary as a goal of our game. The user uses keyboard and mouse to control the figure bouncing between the obstacles to reach the cookie. Once the cookie was reached, the renew cookie functions will be called and delivering a new cookie randomly again. Now for lighting and the shading effect, we implement a 2-point light source along the diagonal of our boundary box. And here's our feature innovations. We developed this project into a small game. So by clicking the left mouse button, the user can reverse the gravity around the z-axis. Also, the velocity in 3-dimensional can be controlled by the keyboard. WASD on the keyboard controls the figure speed in a horizontal plane. And then there's a tiny green cube you can see in the box. So the user's mission is to touch this green cube with our triangle mesh by controlling the velocity in 3 dimensions and the gravity, and while avoiding touching those obstacles. And the shading effect and lights are also implemented. And that's our project demo. Thank you.